Hello, people. Welcome to our channel, Creative Things. Hope all are doing well. Today, we are diving into the fascinating world of HPLC to uncover how this powerful technique can transform your analytical skills and elevate your research. Now, understand what is HPLC. High performance liquid chromatography is an advanced analytical technique which is used to separate, identify, and quantify components in a mixture. It is widely utilized in various fields, including pharmaceuticals, biochemistry, environmental science, and food industries. Due to his high resolution and sensitivity and precision, it is widely used. Now understand the principle of HPLC. When each component dissolved in a mobile phase passes through the stationary phase, the size and strength of each component interacted with the stationary phase are different. Therefore, the residence time of these components in a stationary phase is different, flowing out from the stationary phase at different times, one after another. You can deeply understand the principle of HPLC by looking at the diagrammatic representation of the principles. Let's move on to the next topic, that is components of HPLC. The first one is a solvent reservoir. It holds the mobile phase, which is a solvent or a solvent mixture used to carry the sample through the column. The second one is a pump. It delivers the mobile phase at a constant and precise flow rate and pressure, typically ranging from 1 to 10 milliliter per minute. The third one is an injector. It introduces the sample into the mobile phase stream. This can be done manually or automatically using an autosampler. The fourth one is a column, which is a major part of HPLC and it is a heart of HPLC system. It packed with a stationary phase material, the column's properties and determines the separation process. Fifth one is a detector. It monitors the eluent coming out of the column and provides the data on the components based on their interacting with the detector. Common types include UV visible detector, fluorescence, and mass spectroscopy detectors. Sixth one is a data system. It collects and processes the data from the detector, often displayed as a chromatogram, which shows the separation of compounds over time. There are five different varieties of types of HPLC. The first one is a normal phase HPLC. Uses a polar stationary phase, for example silica, and a non-polar mobile phase, example hexane. It is suitable for separating non-polar and weakly polar compounds. The second type is a reverse phase HPLC. It is a common type of HPLC. It is ideally used for separating polar compounds. It uses a non-polar stationary phase, for example C18 and C8, and a polar mobile phase, water methanol combination or a water acetonitrile mixture. And this is a major part of HPLC and highly used. The third one is an ion exchange HPLC. It uses a charged stationary phase to separate ionic compounds based on their charge. It is commonly used for separating proteins, peptides, and nucleotides. The fourth type is size exclusion HPLC. It separates molecules based on their size using a porous stationary phase, useful for large biomolecules like proteins and polymers. The fifth and last type is affinity HPLC, uses a stationary phase with a specific binding sites to separate compounds based on their biological affinity, often used for separating proteins. There are different steps in the HPLC analysis. First one is preparation of mobile phase. The solvent or a solvent mixture is prepared, often requiring degassing to remove air bubbles. The second step is sample preparation. The sample is filtered and dissolved in a suitable solvent to prevent clogging the column. Third one is a system setup. The HPLC system is set up and the column is equilibrated with a mobile phase. The fourth step is sample injection. The sample is injected into the mobile phase stream. Fifth step is the separation. As the sample passes through the column, its components separate based on their interactions with the stationary and mobile phase. The sixth step is a detection. The separated components are detected as they elute from the column. The seventh step is a data analysis. The detector signals are processed to produce a chromatogram, which is analyzed to identify and quantify the compounds. These are the steps in the HPLC. You might be wondering how this applies to your work. Now let's dive deeper into how this works. These are the applications of HPLC, which is used in food and beverage industry for analysis of additives, preservatives, and nutritional content, detection of contaminants and adulterants. It is also used in the biotechnology and biochemistry, proteins and peptide analysis, analysis of nucleic acids and other biomolecules. In environmental studies, this technique is highly used for detection of pollutants and contaminants in water, soil, and air samples. There are many applications for HPLC. The fourth one is pharmaceutical industry, quality control and purity testing of drug separation and analysis of complex mixtures of pharmaceutical compounds. In the clinical chemistry also it is used for analysis of blood, urine and other biological samples for diagnostics and research purpose. It is used in the qualitative and quantitative analysis of the compounds. When it comes to advantages of HPLC, it has a high resolution power, can separate complex mixtures with a high precision, and speed it offers makes it highly usable, faster analysis compared to traditional methods, and it is highly sensitive, capable of detecting low concentration of compounds. It's highly versatile, applicable for the wide range of substances, including both organic and inorganic compounds. Its qualitative and qualitative analysis provides both identification and quantification of compounds. Even though it is a highly utilized system, it has some limitations. The first one is a cost. Equipment and maintenance can be expensive. Complexity, it requires technical expertise to operate and interpret results. And sample preparation. The sample preparation process is tedious in HPLC, often requires extensive preparation to avoid column damage. The fourth limitation for HPLC is a solvent use. It can be costly and requires proper disposal due to environmental concerns. The bottom line for this session is HPLC is a powerful and versatile analytical technique which is essential for modern scientific research and industrial application. Its ability to separate, identify, and quantify compounds with high accuracy makes it invaluable in various fields. If you found this video helpful, give it a thumbs up and subscribe for more insights and tips. Don't forget to like, share, subscribe.